Welcome to the RAOB program's 3D Hodogram. All examples shown in this video require use of the optional Hodograph and Interactive Program module. We'll start with the sounding from southern Florida. It has southerly surface winds, westerly mid-level winds, and easterlies above the tropopause. Looking at the mini hodograph with all winds plotted, it looks like a jumbled mess and hard to tell which end is up. And when we expand the mini hodograph to full screen size, it doesn't look much better. But if we go to the Displays menu and then select the 3D Hodogram, we get a whole new perspective on the wind profile. Remember that the RAOB hodograph is a vector diagram. This hodogram is a trajectory diagram. This diagram depicts the three-dimensional voyage of the sounding balloon from launch to burst. And even though some sounding data files contain data where the balloon descends, RAOB only displays and analyzes the ascent phase. Before we demonstrate the three-dimensional view, let's first look at the basic structure of this hodogram trajectory as viewed from space. The sounding slowly drifted northward due to southerly low-level winds. Then the sounding moved in an eastward direction due to a deep mid-level layer of westerly winds. And finally the sounding turned southward a bit before drifting westward under the influence of a layer of easterlies above the tropopause. Also note the distance scale at the bottom, where each ring reflects a 5-mile range. We can change this to kilometers by calling up the Hodogram Options panel with a mouse right click. We'll use the Format tab to change the scale to kilometers. And also note above you can change the depth of the diagram if needed. And by clicking on the Wind Data tab, you can see other options. And while we're here, let's also change the wind speed units to meters per second. And then apply the changes. So let's now take a look at this trajectory in 3D. Just click on this auto rotation option to start the rotation. Notice that as it rotates, the vertical tilt and the azimuth view values constantly reflect the hodogram's orientation. And to stop the auto rotation, you can use the escape key or just click on this stop box. And now notice these 4 arrows. You can click on them to separately rotate the hodogram's vertical and azimuth angles 1 degree at a time. Or you can use the keyboard's arrow keys to make the same adjustments in a little faster motion. And now we'll adjust the profile to view it from the south. With this view, a new distance scale appears at the bottom for reference purposes. And here you can again see how the sounding drifted eastward in the layer of westerly winds, and then drifted westward in the layer of easterlies. Now let's go back to those 4 arrow controllers and notice the black dot in the middle. When clicked, it resets the hodogram to its original orientation, like this. And now for the last demonstration, we'll load a LiDAR sounding. We could load it here, but instead we'll first return to the sounding diagram using the Displays menu. Then we'll load the LiDAR sounding, and note that it only contains wind data. However, it does contain vertical wind or W component winds. Here you can see the upward winds are in red shading, while the downward winds are in blue shading. And now we'll use the Displays menu to select the 3D Hodogram view. And now we can again see the red and blue vertical wind shading designations. Before we rotate the hodogram, let's increase the profile thickness to better see the color variations. And now we can start the auto rotation in motion. And that completes the RAOB program's 3D Hodogram demonstration. Thank you for watching.